Welcome to qnawire.
In this question, we have a circular cam that rotates about a fixed point O, and with constant angular velocity omega. We need to determine the velocity v of the rod AB as a function of theta. Okay. So the first thing we need to do is to write down the position coordinate equation for the rod, which in this case we'll be looking at the x coordinate of A. Okay, so we'll set origin at at O. So using the law of cosines, this is the triangle that we'll be looking at. So from the center of the big circle to point O, and then draw a horizontal line to the center of the small circle, and then connect back to the center of the big circle. So in this big triangle, okay, so this side is D, this is angle theta, the bottom side is X, and then the other side would be R plus small r, big R plus small r, okay? So the law of cosines gives us x squared plus d squared minus 2xd cosine theta equals to r plus r squared. Okay, and then we take the time derivative. Then we have 2x, x dot, plus 0 minus 2x dot e cosine theta plus 2x d sine theta dot equals to 0. So, and then we know that x dot is v, and then theta dot is omega. So we have v equals to x d omega sine theta divided by d cosine theta minus x. So here we will need to replace x. So going to call this equation 1. I'm going to replace x from the law of cosine equation. Okay, so from 1, we have x squared minus 2xd cosine theta plus d squared minus r plus r squared, big R plus small r squared. And then going to do quadratic equation. So x is equal to 2d cosine theta plus minus d squared, which is 2d cosine theta squared, minus 4 d squared plus 4 r plus r squared. And this whole thing square root. And then the whole thing, the whole numerator divided by 2. So gain the 2 square in the square root and the 4 inside the square root can be factored out. So we are going to get d cosine theta plus minus d square cosine square theta minus d square plus r square, then square root. So d square cosine square theta minus d square is can be simplified. Okay. So we have r plus r square minus d square sine square theta. Okay. So based on the diagram, I'm going to choose the positive root for x. Okay, choose the positive root for x, so x is equal to d cosine theta plus r square minus d square sine square theta. Then recall that our v is equal to x d omega sine theta divided by d cosine theta minus x. Okay, so I'm going to replace the x using this equation. Okay, going to replace x inside here, so we get d omega sine theta times d cosine theta plus square root term r plus big R plus small r square minus d square sine square theta divided by negative the square root term. Okay, so simplify minus d omega sine theta 1 plus d cosine theta divided by the square root term. Okay, so here the v is negative, so it's very clear that and it's consistent with what we know in this diagram. Okay, so we know that the x is to the right, okay, and then the v is to the left. Okay, this is consistent with the setup of the problem. Okay, so that's all for this question.